Hello, future engineers. Today, we're diving into a fundamental concept in design and problem solving: modularity. This isn't just for software engineers. It's a powerful way of thinking that can be applied to almost any complex system. By the end of this video, you'll understand what modularity is, why it's crucial, and how it can make your designs more robust and adaptable.
At its core, modularity is about breaking down a large, complex system into smaller, independent, and interchangeable components. Think of it like building with Legos. Each brick is a module, designed to perform a specific function and connect with other bricks through defined interfaces.
There are several key principles that guide effective modular design. Today, we'll focus on two of the most critical: high cohesion and low coupling. These two concepts work hand in hand to create truly effective modular systems. Why should we care about modularity? Because it leads to systems that are easier to build, maintain, scale, and understand. It allows different teams to work on different parts simultaneously, accelerating development and reducing complexity.
First up, high cohesion. Imagine a toolbox. A highly cohesive toolbox would have all screwdrivers in one drawer, all wrenches in another, and so on. Each drawer, or module, has a clear, single purpose. In design terms, high cohesion means that the elements within a single module are functionally related and contribute to a single, well-defined purpose. A module should do one thing and do it exceptionally well. When a module has high cohesion, it's easier to understand, test, and maintain. If something goes wrong, you know exactly where to look because the module's responsibilities are clearly defined.
Next, let's talk about low coupling. If high cohesion is about keeping things that belong together inside a module, low coupling is about keeping modules independent from each other. Coupling refers to the degree of dependency between modules. High coupling means modules are tightly linked, like a custom car frame and its doors. Low coupling means they're connected, but loosely, like a door handle and slab door. With low coupling, changes within one module are less likely to impact others. This promotes flexibility, reduces ripple effects when updates are made, and makes it easier to replace or upgrade modules without affecting the entire system.
So how do we apply these principles? It's about consciously designing systems with independent, well-defined components. It's about thinking about responsibilities and interactions. In software development, modularity is evident in object-oriented programming, where objects are modules, and in microservices architecture, where entire applications are broken into small, independent services.
But it's not just software. Think about a car. Its engine, transmission, and braking system are all modules. Each is designed to do its job, and they connect through standard interfaces, allowing for easier maintenance and upgrades. By embracing modularity, you can build systems that are more robust, flexible, and adaptable to future changes. It's a design superpower.
Remember, high cohesion and low coupling are your guiding stars for effective modular design. Thanks for watching, and keep building amazing things. For future development crash courses, please click subscribe.